we are going to do Unit 9, Day 6, Use Normal Distributions, Day 1. To get started for today, what you will need is a calculator, and you might want to have some additional colors, maybe a highlighter, to help you with some of the things that we're going to be doing today. So in our warm-up section, what I would like you to please do is I would like you to please create like a bell shape. And what I'm going to do is I'm going to explain these pictures that I have right here in this space up above. And today we're going to talk about what a normal distribution actually is. Now, you might have heard the phrase that a teacher is going to curve the test, or you might say that you were above the curve, or like the typical like you might have heard that somebody earned a score in a specific percentile. Whenever we talk about that, we are referring to normal distributions and how somebody compares to something else, and what we would expect all of our data values to be located. So a probability distribution is modeled by a bell-shaped curve, referred to as a normal curve, and it is symmetric about the mean. So at the very center of this bell-shaped curve is our mean, and we can refer to it as X bar, just like we did in our last lesson. And what we are interested in is we are interested in the area underneath the curve to represent what proportion of the curve we are referring to. So a normal distribution with a mean of X bar and a standard deviation of lowercase sigma has the following three properties. The first thing that I want you to know is that to represent a total area, if we were to shade everything underneath, that full area, the total area underneath the curve, is 1, and that it represents 100%, which would make sense. If we're shading out everything, that number 1 is going to be what our 100% is written as a decimal. So that's what we have right here. And if we were to cut a line going right down the middle where our mean is, we would say that 50% of our data is below our mean and 50% of our data is above the mean. But what we are actually interested in is where our data values are with respect to the standard deviations. And so if you can imagine one standard deviation, if we were to cut this into like different equivalent bars, this distance right here would represent one standard deviation below the mean. And this point right here would represent one standard deviation above the mean. And each of these areas represent 34% apiece. So 34% or 0.34 if we wanted to write it as a decimal of the area. So if we were to shade this block right here, we would be shading 34% of our curve. And if we shaded this block, it would represent 34% of our curve. And in between one standard deviation above and below the mean, 34 plus 34 is naturally 68%. So 68% of the area lies within one standard deviation of the mean. So that means that above or below one standard deviation of the mean, 68% of our information lies right there. If we wanted to look at two standard deviations, so kind of draw out another like line on each side that's about the same distance as what you had before, making each of these blocks pretty much equidistant. This would represent two standard deviations below the mean, so I'm using a negative number to represent that, and two standard deviations above the mean. And this block right here, if we were to talk about just that space, this space right here represents about 13.5% of the area underneath the curve. Same thing with right here. This is 13.5% of the curve. And notice that it's not nearly as high as the other pieces. It's not going to represent nearly as much of the area of the curve. We typically write these as decimals. I do want you to know as well, like this is represented as 0.34 and 0.34. And these decimals are represented as 0.135 and 0.135. And I know that you already know that, but that is something that we use in when we are using a normal distribution. And so therefore, if we wanted to talk about from beginning to end, from 2 standard deviations below the mean to 2 standard deviations above the mean, that full distance straight across, if we were to shade everything in between plus or minus 2 standard deviations, that is a total of 95% of the space underneath the curve. So 95% of the area underneath the curve lies within 2 standard deviations of the mean. So that is plus or minus 2 standard deviations. The last one that we have is within 3 standard deviations. So I want you to draw probably about an equidistant box that we had before on each side. And this represents -3 standard deviations and +3 standard deviations. And just this little space right here doesn't represent a very huge section of our curve. And instead, this, if we were to write it as a decimal, represents 2.35% of the area underneath the curve. So this is 2.35%. And if we wanted to represent it as a decimal, that would be 0.0235. And I need you to know both the percent as well as the decimal. Please be very careful when you are writing these as a decimal. We need to have that 0 that is inserted. And if you were to add up all of these spaces going all the way from left to right, from -3 standard deviations below the mean all the way up to 3 standard deviations above the mean, that would represent a total, and I think that where I want to put it is, I guess I'll put it right here, is 99.7%. So this is 99.7% of the area lies within 3 standard deviations of the mean. So that's plus or minus 3 standard deviations. The remaining sections, which are these sections right here, which is above or below 3 standard deviations, they are considered outliers, statistically speaking. And because if anything is 3 standard deviations above or anything is 3 standard deviations below, that is way outside of what we would expect. And so we would call those outliers. Outliers above or outliers below. And the percent of those outliers are 0.15%, which we write as a decimal as 0.0015. So that's percent and then decimal. And so we have this equivalent numbers on the other side. 0.0015 is our decimal, which is equivalent to 0.15%. So that's a 1 right there. So that is a very, very, very small area underneath the mean. But what you would see is, like, if we were to have like an average on a test, we would expect that most of our students, if we took this test, would be very, very close to where the class average is. And then as you have fewer students that will get above and fewer students who will be below the average of the class, for example, if we were to talk about a test. So I have written down here all of the same exact percentages, and I need you to be aware of both of them. So you notice that I use just minus and plus or negatives and positive standard deviations, and this is with respect to the mean. So another way that you can write all of the same numbers that I just had is x bar plus 1 standard deviation, x bar plus 2 standard deviations, x bar plus 3 standard deviations, and likewise the same exact thing on the other side, x bar minus 1 standard deviation, x bar minus 2, x bar minus 3 standard deviations. And so I have all of these written out for you, and I need you to look at these, and I need you to know and study these pictures. So please make sure that you study them. I need you to know each of the individual percentages or decimals, and I need you to know each of the ranges, so that between plus or minus 1, it's 68%, between plus or minus 2 standard deviations, it's 95%, and between plus or minus 3 standard deviations, it's 99.7%. Please make sure that you know and study these tables. So please make sure that you do that. All right, let's go ahead and use these tables to help us to actually identify our probabilities. So whenever we are referring to like the percentage underneath the area, what we are actually referring to is what is the probability that a data value lies within a certain range that lies underneath the curve in a specific shaded area. So in example number 1, we are told that a normal distribution has a mean of, this needs to be X bar, and a standard deviation of lowercase sigma. For a randomly selected X value from a set of data from the distribution, find the probability that the randomly selected data value is in less than or equal to your mean plus 3 standard deviations above the mean. So when we think about where that is located, we are looking at where 3 standard deviations above the mean is, and we want everything that's below it. So we are interested in shading all of these different spaces. So every single one of these spaces are going to be shaded. So on your homework, there's going to be some problems that will provide you with some normal curves already given. And then there's going to be others that are going to not have them on there, and you'll have to draw them on their draw them for yourself on the assignment. So what we're going to do is we're essentially going to add all of our percentages together, going all the way up into the part that we are not interested in. And this is the part that we are not interested in. So I'm going to add 0. We want to have, well, we can use a decimal, or we can use fractions or percentages, excuse me. So I'm going to write 0.0015 plus 0.0235 plus 0.135 plus 0.34 plus 0.34 plus 0.135 plus 0.0235. And I think that that is it. So I've added all of the parts that I want together. And I just went right down the line. This little piece plus this little piece plus this one plus this one plus this one plus this one plus this one. And if you wanted to, you could have said like all of this should add to 50% plus 0.34 plus 0.135 plus 0.0235. And when you add all of those numbers together, you're going to end up with 0. And you'll put this directly into your calculator, 0.9985. And you might be looking at that and saying, Mrs. Oliveira, there's got to be a faster way. And there absolutely is. So I want you to also think complements, because we're using inequalities. So sometimes complements actually make the most sense. As we can clearly see, most of this area has been shaded. And that is really easy to see. And the only part that we don't want is this section right here. So another way that we can express our probability is to write that this is equivalent to 1 minus 0.0015. And that number also equals 0.9985. And if we wanted to write our answer as a decimal, then this would be equivalent to 99.85%. So this is it written as a decimal. This is written as a percent. It all depends on how the problem has been expressed to you. This one was non-specific as to how they wanted their answer to be expressed. But just know that when it comes to these types of problems, there are multiple ways to approach each of them. So I want you to be open to what that is. All right, let's go ahead and look at letter B. In letter B, we want to find the probability that X bar is in between 2 standard deviations below the mean, and so that our X data value is in between 2 standard deviations below the mean and 1 standard deviation above the mean. So where we are looking is we want in between 2 standard deviations below the mean, which is all of these spaces, going all the way up to 1 standard deviation above the mean. So these are our spaces that we're going to be adding together. So I am simply going to add 0.135 plus 0.34 plus 0.34. You could also recognize that this is basically 0.68, and then you're adding an additional 0.135. I'm open to whatever you do. Just show me what you're putting into your calculator. Show me what you are adding together. And when you put that into your calculator, you're going to end up with 0.815, which if you wanted to write that as a decimal, that would be 81.5%. All right, let's go ahead and flip the page. And what I have here are two problems that are pair questions. So what I would like you to do is I would like you to please pause the video and I would like you to please try these on your own. Notice I did not provide a picture, so I want you to try to draw a quick sketch of what each situation actually is. When you have an answer, please go ahead and restart the video and we will see how well you did. Okay, so let's go ahead and look at letter C. For letter C, we have the probability that X is greater than or equal to 2 standard deviations above the mean. So what I'm going to do is I'm going to draw a quick bell shape. And I'm going to do my best. Not all my bell shapes are super perfect, but it is what it is. And I am going to mark where my X bar is because it's always important to show me where X bar is. Here's about 1 standard deviation above the mean. Here's about 2 standard deviations above the mean. So here's 2 standard deviations above the mean. And we want our values of X to be greater than or equal to. And honestly, the equal to doesn't mean anything because equal to would mean what's the area of a line, and a line doesn't have any area. So don't worry about whether it's equal to or not equal to. The area underneath is going to be the exact same. But we want greater than or equal to. So I'm going to mark that about right here is 3 standard deviations above the mean. And so this decimal is 0.0235, and this section is 0.0015. So I am simply going to add those two numbers together. So 0.0235 plus 0.0015, and those two numbers added together is equal to 0.025, which is equivalent to 2.5%. All right, the next one that we have is letter D. And letter D, we want to find the area underneath the curve that is between 1 standard deviation below the mean and 3 standard deviations above the mean. So I'm going to draw a quick sketch of what this looks like. I need to see the sketches. And I'm going to mark where X bar is located. And here is approximately where 1 standard deviation below the mean is. And I'm going to mark here's 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. And I want any data value that's going to lie in between this space right here. So if I were to add all of my percentages together, you can see that we have between plus or minus 1 standard deviation. So that section right there is 0.68. And then this section is 0.135. And then this section right here is 0.0235. And so those are going to be all of the numbers that I'm adding together. So I absolutely just need to see what numbers you added together. And if you added 0.34 plus 0.34, there is nothing wrong with that. But just show me what you are putting into your calculator. This is how you are showing work, and that work is very small amounts of work, and you can definitely handle doing that. And if you put that into your calculator, you would end up with 0.8385, which is equivalent to 83.85%. And that means that you have an 83.85% chance of being a data value that's in between 1 standard deviation below the mean and 3 standard deviations above the mean. All right, let's go ahead and look at example number 2. And we are now kind of bringing in some context of how this would be used. So in example number 2, it says the math scores of the 2004 SAT are normally distributed with a mean of 518 and a standard deviation of 114. So what we're going to do is I'm going to mark up that this X bar is where 518 is. And what I want to do is figure out what is one standard deviation above the mean. So all you have to do in order to do that is you take 518 and we're going to add one standard deviation. And that score ends up being 632. So 632, that score is one standard deviation above the mean. And then I'm going to take 632 and I'm going to add another 114. So that is two standard deviations above the mean. So that is 746. So if you have a score of 746, that is two standard deviations above the mean. Then I'm going to take that number and add another 114 and we get 860. So a score of 860 is three standard deviations above the mean. Okay, so over here, I'm going to go back to 518 and I am going to subtract 114. And when I do that, I end up with 404. So the score of 404 is one standard deviation below the mean. And then I'm going to take 404 and subtract 114 from that, and I get a score of 290. So a score of 290 is two standard deviations below the mean. And then I'm going to subtract 114 from that, and I get 176. So a score of 176 represents a score that is three standard deviations below the mean. So if you want to put in those standard deviation symbols just to give you that visual, there's nothing wrong with that. Here's our X bar. And that is just filling out our information based on what was already given to us. So now what we want to do is we want to figure out what percent, so this time we want percentages, what percent of test takers have scores between 518 and 746. So what I'm going to do is I'm going to draw a really quick sketch of what I'm interested in. And so we want to figure out what is the probability that a score is in between 518 and 746. And that's how we would write it as a probability. And I'm going to be looking for that on your homework. So 518, that is X bar. And 746, well, that is two standard deviations above the mean. So the space that I'm looking for is this space right here. And so this area is 34% because we're working with percentages. And this area is 13.5%. And so that's what I'm going to be adding together, 34 plus 13.5. And that number ends up equaling 47.5%. And that is our answer. For letter B, what we want to do is figure out what percent of test takers have a score that is less than 404. So I'm going to draw a really quick sketch, and we can see that 404 is one standard deviation below the mean. So we want to figure out what is the probability that a randomly selected value has a score that is less than 404. So here's where X bar is. We always draw X bar. And then we want one standard deviation below the mean, which is 404. And that is one standard deviation below. And then we want values that are less than that. So I'm going to show you how I would approach this. Do you see how 50% would go from X bar all the way down? And the only part I am not interested in is 34%. So one way that I can approach this is by simply taking 50% and subtracting away the part that I do not want, which is 34%. And what I'm left with is 16%. So another way that you could do this is you could add 15% plus 2.35% plus 13.5%. 5%. So that's another way you could do this. So I'll write that down. Another way you could write it is you could go 0.15% plus 2.35% plus 13.5%, and that'll still get you 16%. So both ways will certainly get you the right answer. Okay, let's go ahead and look at letter C. For letter C, it says about what percent of test takers have a score that is between 404 and 632. So we want to score between 404 and 632. So I'm going to start by drawing my normal distribution curve. So we are always doing that for every single problem. And we want a probability that the score is in between 404 and 632. Okay, well, 400, here's where X bar is. So we always draw that in. And here is one standard deviation below the mean, which is a score of 404. And then a score of 632 is one standard deviation above the mean. And we want this area right here. And we already know that that is 68%, because anytime that you're plus or minus one standard deviation above and below the mean, that is 68%. Let's go ahead and look at letter D. For letter D, it says what percent of test takers have a score that is greater than 746. So let's go ahead and graph a picture of what this would look like. Always draw our standard normal curve. Here's where X bar is. And 746 is 2 standard deviations above the mean. And we want to find the probability that a randomly selected test taker had a score greater than 746. So we're interested in this space right here. So when I'm looking at this, one thing that you could do is you could recognize that here's 3 standard deviations above the mean, and this space right here is 2.35%, and this space right here is 0.15%. So we are just simply adding the numbers 2.35% plus 0.15% to give a total of 2.5%. And that is our answer. All right, let's go ahead and do one more for good luck. Let's go ahead and flip the page. Or we have a couple more for good luck, excuse me. So looking at example number 3, it says the typical amount of sleep that per night that college students receive is normally distributed. So this is a typical amount of sleep per night for college students is normally distributed with a mean of 7 hours in a standard deviation of 1.7 hours. So that's not a lot of, that's a pretty decent chunk of our standard deviation for our numbers being away from the mean. I'm not going to lie. So you'll see that in just a second. So they're saying that the average number of hours of sleep is 7. So just like I did before when I created this, I'm going to take 7 and I'm going to add 1.7 since that's my standard deviation. And that ends up equaling 8.7. And 8.7 is one standard deviation above the mean. So then I'm going to add another 1.7, and that equals 10.4. That is 2 standard deviations above the mean. And then I'm going to take that 10.4 and add another 1.7, and we end up getting 12.1. And that is 3 standard deviations above the mean. So now I'm going to go back to 7, and instead of adding 1 standard deviation, I'm going to subtract 1 standard deviation. So I'm going to subtract 1.7. And I end up with 5.3, which is 1 standard deviation below the mean. And then I'm going to take 5.3 and subtract 1.7, and I get 3.6, which is 2 standard deviations below the mean. And then I'm going to take 3.6 and subtract 1.7. And when I do that, I end up getting 1.9, which is 3 standard deviations below the mean. All right, so we filled that out because it's very useful in helping us to create our shaded space. So what we want to do is figure out what percent of college students sleep between 5.3 hours and 8.7 hours. So let's go ahead and draw a quick sketch of what that would look like. Here's my X bar. And that is, and 5.3 is one standard deviation below. So I'm going to write 5.3, which is one standard deviation below. And then 8.7 is one standard deviation above. And I am interested in this shaded space, which anytime that you are in plus or minus one standard deviation of the mean, we know that that's 68%. So I want to find the probability that their sleep is in between 5.3 and 8.7. So I want to see this probability statement. And if you already know that it's 68%, then that is perfectly fine, but I do want to see you write it out properly. All right, let's go ahead and look at letter B. For letter B, we want to figure out for what is the interval in hours of sleep for 95% of our college students. So let's remember what 95% of our college students, where would that be? So remember that right here at X bar, from one standard deviation above and below, that was 68%. Two standard deviations above and below, that was 95%. So we are looking in between plus or minus two standard deviations of the mean. So this is the area that we are looking in. So what data values were two standard deviations below and two standard deviations above? And those values end up being at 3.6 hours and 10.4 hours. So the interval in hours of sleep is between, so I'm going to write between 3.6 hours and 10.4 hours. And that's how you would just simply write your answer. You could also write it in interval notation between 3.6 and 10.4. That is writing in interval notation. And this is hours. Okay. Let's go ahead and look at the team question. I think that after you saw the ones that we just did, I think you can handle the team question on your own. So if you wouldn't mind pausing the video and attempting this problem, that would be a great thing. And when you are ready, please restart the video and we will see how well you did. Okay. So for this team question, it reads that the blood cholesterol readings for a group of women are normally distributed. So we want the blood cholesterol readings for a group of women are normally distributed with a mean of 172 milligrams per deciliter and a standard deviation of milligrams per deciliter. Sketch a picture of the normal curve to help answer the questions. So I like to go ahead and get started by writing this as 172 is my X bar, and then I'm going to add 14 to above every single time. So that's going to give me 186, represents one standard deviation above the mean. The next one is 200, is two standard deviations above the mean. And the next one is 214, is three standard deviations above the mean. 158 is one standard deviation below the mean. Well, a score of a 144 is two standard deviations below the mean. And a score of 130 is three standard deviations below the mean. Okay, so that helps us because now what we want to do is we want to figure out what percent of women have readings that are between 158 and 186. So I'm going to draw a quick sketch of what that looks like. And we want between 158, so here's where X bar is, and 158 is right here, and that is one standard deviation below the mean. And 186 is one standard deviation above the mean. And once again, we are having the answer be 68%. So I'm going to be looking for you to write the probability that a randomly selected female has a value or a score or reading in between 158 and 186, and that is equal to 68%. So let's go ahead and look at letter B. It says the readings higher than 200 are considered undesirable. So what percent of the readings are considered undesirable? So if you think about that, a score above 200, here's our standard deviation. One standard deviation above was 186. 200 is two standard deviations above the mean. And we are interested in all of the space that is larger than that, so higher than 200. So this is the space that we are interested in. And 3 standard deviations, I'll give you the color, 3 standard deviations above the mean is about right here, and that is at a score of 214. So essentially what we are adding is 2.35%, and we're adding 0.15% to find the probability that a randomly selected female has a score greater than 200, because that's considered undesirable, and that equals 2.35% plus 0.15%, which gives us 2.5%. And that is the end of this lesson. If you have any questions over what I just showed you, please make sure that you email me. Otherwise, I hope you have a wonderful day.